La prochaine intervention, elle va se faire en visio. Carlos?
Yes, can you hear me?
Yes, we can hear you. And sorry for my English.
I need permission.
You can share your screen, or I can.
I can try. Yes.
Yes, go. Try. Let's go. See.
Yeah. It's showing.
Yes.
Okay. Okay. Perfect. Good afternoon to everyone, and bonjour. Is the only French word that I can mention, and I hope you are having a good journey in France. And I will present very shortly what we did in this experimental campaign in terms of assessing the performance of connections from timber concrete solutions. And this work here is only the Portuguese team members, but we had this activity in collaboration with SerQ, namely Gonzalo Moltini, Gonzalo Cabrera, and Vanessa Banho, also have been part of the work that I will present. Okay. So the main goal that we have in this activity was to promote the use of local species for the production of engineered wood products. So we know that nowadays we use mainly glulam beams and CLT, and we want to promote the use of these local species for the production of CLT and other developed products, namely the combination with the concrete. And this combination allows us to promote the use of the most important mechanical properties that we have in both materials. And for that, we start to assess the mechanical performance of these connections, namely the stiffness of the connection and also the load carrying capacity. And based on that, we can see here in this figure in the right corner, in the down part, that if we have a kind of connection without being stiff, we don't have the good connection, the good performance of the solution. So we have different separate behavior of the materials. So we try to study different connections to propose a solution that can be stiff and also very interesting in terms of local economy. And for that, we considered maritime pine from Portugal forests, and also radiata pine and Scots pine from Spain. And as you know, we have more than 100 years of development in terms of connections for this kind of solutions. And the stiffness and load carrying capacity is detailed here in this figure, this graph. And we know clearly that dowel type connections usually are not stiff, but they have a good performance in terms of ductility. However, if we go to glued joints, we increase the load carrying capacity, the stiffness, but they are too much fragile. So we expect to achieve performance that should be midway in these two kind of solutions. Also, another thing in terms of state of the art, that there are different types of tests that the scientific community have performed. And for this campaign, we followed the double shear test, as it is nowadays recommended in technical data sheet that has been approved and is nowadays as a rule. So for that, we decided to use different, or to study different types of connections. Most of them, well, all of them were with notches, perpendicular notches with the screw to avoid the uplift between the materials, but also notches with inclined notch, so we can avoid the use of the screw, preventing the uplift between both materials. And we assess different types of conditions with different lengths of the notch and also different depths, as we can see here in the right figure. So, as I mentioned, the technical data sheet presents a configuration for the test. We assembled first separate the CLT elements were glued in a separate condition. We cast the concrete in situ and also other solution like prefabricated specimens, and then we bond the two CLT elements already with the concrete to have a double shear test. And this is the specimen and the layout of the tests that we have carried out at SerQ. These are the most typical, or at least the four types of failure modes that we have found, and the technical data sheets give us as failure modes for this kind of shear tests, and we have observed all of them in the specimen. So the crash of the timber, the shear on timber, also the shear of concrete, as well as crash of concrete. And some of the specimens failed only on one shear plane, and the other keeps its performance without having a failure. And we can see also the different types of connections here for maritime pine. So the letter M is for maritime pine, but we have also this for the Scots pine and radiata pine. In terms of results, what we have observed is that the technical data sheet has a recommendation of 150 millimeters of length from notch, and we try to assess the performance of the length of 90 millimeters to understand if we can reduce the length, we can more or less have less powder in terms of production and reduce the amount of concrete in the notch, but the performance was also influenced by that. So we have clearly the highest load carrying capacity for the reference condition for maritime pine, and the stiffness was higher for radiata pine specimens. The remaining specimens that were without the 150 millimeters, usually it was observed a very fragile behavior in the specimens, and these ones here, the lowest load carrying capacities and this kind of ductile behavior was mostly observed in the prefabricated specimens. So we have precast small plates of concrete, and then we power, we had a hole of 90 millimeters square in the middle of this concrete plate, and then we placed a grout to connect both materials, timber and concrete. And those tests with perpendicular notches revealed a bit of ductile performance in terms of connection behavior. And now I have here a brief, short video, and just to show you how it was during the tests. Of course, this is a kind of 15 millimeters, 15 minutes of testing for each test, and or at least 15 millimeters per shear plane slip. And just to show you the failure modes that we have observed. The concrete has also some, in this kind of connections, we tested with a steel mesh inside the concrete. And you can see different lengths of the notch, also here perpendicular notch with 20 millimeters depth. And you can see also both types of failure. And in this case, we have inclined notch with shear on timber in both shear planes. Oh, sorry, but that's all I have to show you.